Hey everybody, this is Gregory from Dapp University. Welcome back to this multi-part tutorial where I'm showing you how to code your own cryptocurrency and your own ICO website from the ground up, step by step. In this video, we'll be talking about the token sale contract. This is the smart contract where we'll actually allow accounts to buy our Dapp tokens in our ICO. So if you haven't seen the previous videos already, be sure to check those out in this series. And be sure to subscribe to the channel and turn on notifications with the bell below in order to see the next video in the series when it comes out. And if it's already out, you can just check the link at the end of this video or just watch the next video in the playlist. So if you're just catching up with this part in the tutorial and you want to, grab the code, you can find the project link in the description below. This is a link to GitHub with the code up to this point in the tutorial. And you can follow along with that if you'd like. If you're picking up from the last video or you downloaded the code, let's first ensure that we have Ganache running. This is our local blockchain that we're using for development purposes, and it looks like it's running. So we'll minimize that. We will run truffle migrate to ensure that our local blockchain is up to date. All right. Now let's get into building this token sale contract. We can do that by taking a look at what we'll be building. Let's talk about how the token sale contract is going to work. So essentially, this token sale contract is going to be, the second smart contract that we're developing in this decentralized application, this token sale ICO website. And this is the main contract that the, end user or the account connected to the network is going to interact with when we build out our application. This is the contract that's actually going to facilitate token buying. We're going to, add a function in here that allows, an account to buy some of the Dapp tokens that we coded in the previous videos when we built the Dapp token ERC20 smart contract. So what do we want to do with this smart contract? Well, first we want to provision some tokens to the token sale contract. So what we essentially want to do is take some of the total supply of the tokens that we created in the last tutorial and give them to the smart contract. Now let's talk about that a little more. So if you remember, when we built our Dapp token, this ERC20 token, we gave a total supply. And if you remember in our tests, we set that total supply to 1 million, right? We did that in our migration as well. We said that there are going to be 1 million Dapp tokens. So whenever we create our token sale, we actually want to take, a portion of that total supply and give it to the smart contract of the token sale. So that might be a new concept to you as well. On the Ethereum blockchain, you can hold tokens in your wallet, right? You can have tokens that belong to you. And, we created this balance of function in the last kind of part of the series to keep track of, who owns how many Dapp tokens, right? This takes an address and returns the amount. So if I had, an account connected to the Ethereum blockchain, this would show me how many of these Dapp tokens that I have. But remember, an address can be the address of an external account on the Ethereum blockchain, like my wallet, or the address can be a smart contract. And that's exactly what we're going to do in this token sale. We're going to provision a certain number of tokens from the total supply to our token sale. And that's part of the business use case of building an ICO. That's what they do. Whenever they mint the tokens, they take a portion of them and sell them to the public. That's why it's called an initial coin offering. So that's one of the first things that we'll do. And we'll actually do that in our contract constructor. We'll see that here in a bit. We will set the token price. We want to set, the amount that the tokens are going to be sold for. This will be in Way, which we'll talk about momentarily. We're going to assign an administrator to our token sale. So this is someone who has, the power to do certain things that other accounts can't do on the Ethereum blockchain. For example, we want the administrator to be able to end the token sale at a certain time. And that's exactly what the last thing that we'll do right here. We'll create the ability to end our token sale. Okay, so let's get into building this token sale contract. So I'm going to go to my contracts directory. We'll create a new file. We'll call this Dapp token sale. .sol. All right. You can see that here. And we'll go ahead and create a test for this as well. All right. So we got both the files that we need in order to get started. So let's sketch out our smart contract. Remember, the first thing that we need to do is declare the version of Solidity that we're using. We do that like this, pragma Solidity. We use a caret, 2, and we can declare our contract. All right, we can save that. We did that just like we did in the last video. Now let's go ahead and create a constructor. We'll sketch that out. Remember, a constructor is just a function inside of a smart contract that gets run upon initialization, which is when the contract is deployed. And the constructor function is, just a function with the same name as the contract. And we do that like this. All right. We can say public. All right. Now there's a couple things that we want to do inside this function. The first thing is we want to assign an admin. Remember, this is going to be, an external account connected to the blockchain that's going to have special privileges with this token sale that other accounts won't. For example, we're going to allow the admin to end the token sale. We don't want somebody, just to be able to end our token sale arbitrarily without, permission. So we want an admin to be able to do this. We want to actually assign our token contract. And we'll see this in a minute because we're going to actually have to interact with the token contract that we built in the last part of the tutorial. And we'll set the token price. This will be how much, how much ether it will cost whenever we sell our tokens. Okay. So let's go ahead and assign the admin. We can write a test for this, but before we do that, we need to add a migration. So we'll go to our migrations file. Remember, this is what we created in the last part of the tutorial. These are the migrations that get run whenever we run shuffle migrate and actually update our blockchain by deploying the smart contract. And we want to, deploy this other contract. So there's a couple things that we need to do. First, we'll just import the contract like we did the Dapp token contract. And we'll just update this. Call this Dapp token sale. Remember, this is just reading the contract file out of our contract directory and basically creating a contract abstraction with truffle that we can use, in a JavaScript runtime environment like this. I'm going to add it to this list of deployed objects here. So we'll say deploy, and we'll say Dapp token sale. And we won't, add any extra arguments for the time being. We're actually going to come back and change this in a minute, but I'll just show you the simple version first. So let's go back in here now that we've got our migration taken care of. We'll close the sidebar and open our tests. And we can sketch out a test in order to, build out our constructor. So first we will import our token sale. We do that just like we did in the migration. Same thing, Dapp token sale. And we'll sketch out a test by saying contract, say Dapp token sale, pass in a function. This will give us access to the accounts just like we used in the last tutorial. All right. And let's declare the token instance or token sale instance to keep track of this throughout our promise chains. And we'll write our first test. We'll say it initializes the contract with the correct values. And I noticed that I made a few typos in the last video inside these strings. My apologies. I definitely need some spell checker going on. So just like every other test, we're going to start by returning an instance of the deployed contract. Deployed, then function. All right, and we'll keep track of the instance. First, let's just create a heartbeat test for this contract. We'll just see that it has an address. We can do that like this. You can say return token sale instance address, and I'll say then function. Oops. All right, and this address, we'll just check to see that it's there. We don't necessarily want to check for anything specific because this address is, dynamic depending on our testing environment. We'll say assert not equal, and we can say the address. We do not want it to be, this 0 value. Let's just say it has contract address. All right. You can save that. You can run our tests. All right, passes. So this contract is there. And let's go ahead and assign an admin to our contract. Now, this is something we won't really do in a test-driven fashion because we won't actually expose this admin, and I'll kind of explain that in a second. But first of all, we want to, assign an admin to this contract. So essentially, we want to add an external account that is going to have special privileges with this contract, like the ability to end the sale. So first of all, we'll keep track of this admin address with a state variable. And remember, a state variable in Solidity is just a variable that's going to belong to this entire contract and is actually data that's going to get written to the blockchain. It's going to be written to disk. It's not going to be stored in memory. It sort of kind of belongs to the smart contract when it's deployed to the blockchain. And that's the first thing we'll do in our constructor. We'll say the admin is the person who deployed the contract. And remember, we have access to the person who deployed the contract with msg.sender. And we talked about MSG being a global variable in Solidity that has, a sender, which is just the address of the person who called the function, in this case, who deployed the contract. And we'll make them the admin of this token sale. So the next thing we want to add is actually the token contract. Now, why do we want to add the token contract? We want to add the token contract because we want to actually purchase tokens. So if you look, we have this, transfer function. This is kind of what we will rely upon whenever we want to purchase tokens. We want to, transfer tokens to this address and basically, have this value. And we'll transfer these from the admin that we just assigned. So we can add a reference to our contract, inside of this token sale contract with our constructor. So let's sketch out a test for that first. What we want to do is to see that our token exists, a reference to this token exists within the token sale contract. So we can do that by checking for the Dapp token's address inside here. I'll show you what that looks like. So we'll go down here. I'm just going to turn this over a little bit. We can say return token sale instance. Let's say token contract. All right. And just like we did with our contract address here, we can check for an address in the same way. So we can actually just copy this. All right. This is going to return an address when we implement our token contract function. So the address is not equal to 0x0. So this has a token contract. All right. Run our tests. Uh-oh, got a syntax error here. Forgot to copy the other part. All right, token sale instance token contract is not a function. That's what we expect. So we can implement that. I'll let you guess as to how I'm going to do this. All right, you probably guessed correctly. We're going to add a state variable, but it's going to look a little different than what we did in our last, example. You can see all our state variables here. We're going to introduce a new data type, and that's going to be, a contract data type. And we do that like this. We'll say Dapp token. We'll declare this public. And we'll say the token contract. All right. So this is going to give us a function that we're calling here. That's going to give us an address of this Dapp token that we're going to set inside of our constructor. Okay. So we can run that test. It's going to fail again, but we'll see if there's a new error. All right. So you can see this is not, it failed to compile. So we need to actually implement this in our constructor. So how are we going to get reference to this Dapp token inside of here? Well, we're going to actually pass the address of the Dapp token inside of our constructor so that we can get reference to it here and assign it to our state variable. We do that like this. We use the same data type when we pass it into our constructor. We say Dapp token. and we say token contract. Close this. Token contract, all right. That'll be the first thing that we pass in. And we just want to assign that to our state variable that we declared. Token contract equal to token contract. All right, save that. We can run our tests. Oh, compilation failed. And that compilation failed because it still doesn't know what Dapp token here is. So we'll actually need to import Dapp token. We could do that like this. Import. We can just reference this file name here. We say Dapp token. SOL. All right. Run the test again. All right, so the address, well, we have a new error, right, which is good. It's different from the old error, so we're making progress. But it says the address is still not set like we expect, all right? So how do we actually, get to this address? Well, we need to pass it into our constructor. And just like our token contract, we pass some values into our constructor here. We did that with the migration file. That's the same way that we will pass values into this constructor. So we'll go to our migrations file where we deploy our contracts. Now, when we built this out a minute ago, we just added a new line here, but we're going to have to do something a little fancier. We actually depend upon the address of this contract inside here. So, this deploy function is going to be asynchronous, and it returns a promise. So just like all of our other operations that we've been doing in our tests, etc., we need to use a promise chain. Say then. All right. And we want to say move this side here, return. We want to say Dapp token address. All right, this is our Dapp token here. Here's our address. So we can run this test again, see if that worked. Boom, it passes. All right, so we have successfully set the token contract inside of our constructor. Can cross that off the list. And the last thing that we want to do is set the token price. So let's go to our tests. And we'll add a test for the token price. So we'll say return token sale, token price. All right. And we'll assert that the price is equal to a certain amount. Let's say token price. Let's actually keep track of this price here in our test. Let's set it equal to a value. And I'm going to paste in the value of the token price here. This is going to be way. Let me explain this. So if you're unfamiliar with way, If you're unfamiliar with Way, Way is how we keep track of Ether in Solidity. So Way is the smallest subdivision of Ether. It's the smallest unit of Ethereum cryptocurrency, and we use it inside Solidity so that we're not using floats. We're only using fixed point numbers, and I'll show you kind of what this means. I'll take this value, and we'll open a nice little tool. This is etherconverter.online. This shows you how you can convert, Ether into different kind of, units. We can say, Way and everything else up to 1 Ether, and we can see, larger denominations as well. So you can take a note down here at the bottom. This is the smallest, smallest subdivision of Ether, right? This is Way. So let's paste in the value that I just created. And we can see that our price here is going to be equal to 0.001 Ether, right? So that's how much each of our Dapp tokens is going to cost, of 0.001 Ether. So this is going to be our token price, and that's what we'll test for here. We'll say that the token price, the function that we're calling, returns this price, and it's going to be equal to this variable that we assigned here, which is going to be 0.001 Ether, and we store that in Way. Save that, run our tests. It's going to fail because it doesn't know what token price is. It's not going to know about that function yet. Yep. All right. So the token price is not a function. That's what we expect. So we'll go back to our token sale, and we'll implement that with a state variable. We'll just say this will, so we're going to store Way as an unsigned integer, uint 256. This will be public. This will be token price. All right. Remember, that's going to give us a function for free with Solidity because we declare the state variable public. We don't actually have to write this function out. It's going to just generate it for us automatically, which is nice. And let's keep track of the token price here. We'll say this is going to equal to the token price that we'll pass in. All right. So we can save that, run our tests, see what happens. All right, the function is there, but it's still getting, looks like there's a new problem. We created some side effects from that, but we can kind of fix all of these in one fell swoop. So we kind of messed with our arguments here when we passed everything in. So what we need to do is update our migrations. So in addition to, deploying the contract with the token address, we need to actually pass in the token price. And I'm going to do that like this. Let's just pass in the token price like this. We'll assign it to a variable so that it's a little easier to read. We'll copy this value like this. Oops. All right. And we'll say, let's make a note here. Oops. All right. So token price is something we're going to pass in. Let's try to run our test again. Uh-oh, we got to revert. Let's see where this is happening. Run it again. Boom, it passes. Again, sometimes you'll see these kinds of things with this stage of the game with Truffle. Just try to run the test again. If you see, a cryptic error message like that you don't understand, let's just run it again to ensure that it's doing what we expect. Boom, yeah, passes again. All right, so we have kind of successfully initialized our token sale with the values that we expect. Let me explain one more thing while we're here. So this admin, you'll notice, doesn't have a public visibility set to it like the others. And that's because we don't actually want to expose the address of the admin. I don't think I really sufficiently explained that earlier, so I wanted to tell you now. We don't want to expose the address of this admin. We don't really want to tell people who the sender is. So that's why we didn't test for that here. We just tested for the contract address, that it's there for a smoke test, and we tested for the token contract address and the token price. All right, so that's it for today, guys. That's the first part of our Dapp token sale smart contract. We've created a constructor where we've set an admin for our token sale that's going to have special privileges. We've gotten access to the token contract inside here that we can use for buying tokens later, and we set the token price. We've done all that with our tests. So be sure to subscribe to the channel so that you can see the next video when it comes out. And if it's already out, you can just click the link at the end of this video or just check the next video in the playlist. And until then, thanks for watching Dapp University.